Maria Goeppert Mayer was born to Frederick Goeppert and Maria Nee Wolf, June 28, 1906, in Katowice during the German Empire. Her story is one of perseverance in overcoming gender oppressions. In 1963, Maria was the first woman to win a Nobel Prize for theoretical physics and the second woman to win a Nobel Prize in physics for her proposal of the nuclear shell model. Maria's story starts after she graduated from a preparatory academy for girls. Taking the arbitrary examination in Hanover, then spring of 1924, she enrolled into the University of Göttingen, where she initially studied mathematics. But after attending Max Born's seminar on quantum mechanics, who also took her under his wing despite numerous concerns after seeing her liveliness and passion for her own scientific education, she discovered her passion and focused primarily on physics. One term of her year studying she spent in Cambridge, England, gaining the English language learning experience that would carry her well throughout her later years. During her time at Göttingen, she completed her PhD in physics under 3 Nobel Prize winners, Max Born, James Franck, and Adolf Otto Windaus. She also met her husband, chemical physicist Joseph Edward Mayer, marrying after graduating from Göttingen. She and her husband then accepted an invitation at Johns Hopkins, moving to Baltimore, Maryland. Because of the dated nepotism rules, it prevented the university from hiring Maria as an actual professor, so Maria became a volunteer associate, working with top researchers and continued her drive for physics. During her time at Johns Hopkins, she collaborated with her husband Joseph and Carl Herzfeld, who took interest in her work and together wrote many papers in the study of the color of organic molecules. She was also able to shed light and describe in her lucid manner the nature of the liquid state of a linear model, meanwhile explaining the solidification of liquid helium under pressure. She also developed the theory of double beta decay based on Enrico Fermi's formulation of nucleon-neutrino interaction. She showed that double decay occurred between two nuclei with even numbers, N and Z, both having equal amounts of protons and neutrons. Maria gave the first evaluation of the probability of the 2 consecutive beta decays through the intermediate odd nucleus being forbidden because its energy is higher than either of its 2 neighbors. She also showed that the lifetime of the metastable higher energy member of the 2 even nuclei would be long. Maria Goeppert Mayer was considered a co-equal discussion partner by many esteemed scientists like Max Born, Eugene Wigner, Edward Teller, and Enrico Fermi, who considered her a dear friend. Even through gender oppressions, her liveliness and attitude made her a pleasure to work with and be around, and allowed her to excel further into her career with a reliable and supportive husband. She was able to answer questions on nuclear physics that evaded scientists for years. It was like a jigsaw puzzle. I felt if I only had one more piece of the puzzle, everything would fall into place. I found that piece, and everything became clear. Maria's piece set the curve for not only science, but also a curve for equality among women. Effects of the unstable isotopes of uranium and that it can have on the environment and other particles, as well as having a crucial piece in building a nuclear reactor. But no biggie. The Mayers then published Statistical Mechanics in 1950, a fundamental tool of modern physics. Being a mathematical structure that applies statistical methods and probability theory to large groups of microscopic species, it was a collection done by great minds. Only problem is that all of Maria's work was discredited, because having a woman's name on the cover somehow would have disvalued its proven information. Maria was used to this a lot, working for free for the sake of science. Although she was displeased with this, her love for learning more about physics was enough for her and what made her such a strong scientist. The Mayers remained at Columbia University throughout World War II. Maria started as a part-time substitute. At 58, she was then offered a professor position at Sarah Lawrence College, working 3 days a week and teaching 4 classes and being paid a salary of $2,100, which in present day would be $33,300. From 1942 to 1945, she became the 7th straight-generation university professor on her father's side. Maria's workload was heavy, even in present-day terms. She proved every day just how disciplined she was and would let her drive push her farther into physics. In 1946, the Mayers went to Chicago. Maria was offered a teaching position and finally had a place where she wasn't considered a nuisance. She was a professor in the physics department and was in the Institute for Nuclear Studies. She had also been employed to the Argonne National Laboratory with having very little knowledge of nuclear physics but strong skills and being a quick learner. It took her some time to find her way into this. She carried many discussions with Edward Teller as well as Enrico Fermi, who built a much more supportive environment for Maria, making it rather easy to learn nuclear physics in the Chicago atmosphere. In 1948 to 1949, she started to work on the magic numbers of what would be the nuclear shell method. It took her a year to find an explanation and several years to work out most of the kinks in her thesis. During this time, she met J. Hans D. Jensen, who had a similar thesis and made her believe that she was right. She noticed these repetitions of 7 magic numbers, these being 2, 8, 20, 28, 50, 82, and 126. She made the realization that elements with a magic number of protons or neutrons were consistently more stable than elements with other numbers of protons and neutrons. She also made the comparison that the inside of a nucleus is arranged like layers of an onion, but all the protons and neutrons are arranged in a series of self-working nucleon layers. From 1949, Maria published several papers regarding the stability and configuration of protons and neutrons that constitute the atomic nucleus. These papers helped prove the theoretical science and shaped her theory of the shell model, that the nucleus consists of several shells or orbital levels, and that the distribution of protons and neutrons among the shells produces a characteristic degree of stability that defines each species of nucleus. Maria and her husband had accepted an appointment at the University of California in San Diego in 1960. Maria became a professor in physics, and Joseph became a professor of chemistry. Maria had suffered a stroke, which impaired her speech, but her mind was as keen as ever. This woman could handle it all. Her hobby of growing orchids in Chicago followed her to California and became much more extensive, growing cymbidiums, cataleae, and many more of the orchid family. In 1963, she made history as the second ever woman to win a Nobel Prize for her discoveries to and the development of the nuclear shell model, along with Eugene Wigner and J. Hans Jensen.